All right, today we're going to dive into some of the most fundamental and frankly most powerful building blocks in all of Python. We're going to learn how to move beyond simple scripts that just run from top to bottom and start building smart, powerful programs that can actually think for themselves. So let's get right into it. I mean, really think about that for a second. Most of the code you start with just does one thing after another in a straight line. But the real magic, the real power, well, that happens when a program can look at a situation and actually make a choice, when it can adapt. And that's exactly what we're going to unlock today. So here's our game plan. First up, we're going to see how to make our code smart by giving it the power of decision-making. Then we'll dive into how to build our own reusable tools with something called functions. And finally, the best part, we'll see how to put those two concepts together. Okay, so our very first challenge is breaking free from that boring straight line of code. How do we get a program to do different things based on, well, different conditions? That's where you'll hear this term, control structures. Now I know, it sounds a little bit technical, a little formal, but don't let the name fool you. All it really means is a set of tools that lets us, the programmer, control the flow of our code, basically telling it which path to go down. And the most fundamental of all these tools, it's the simple fork in the road. It's really just the code equivalent of asking a simple yes or no question. And that brings us to the if statement. The best way to think about it is like a gatekeeper. It stands in front of a block of your code and checks a condition. If, and only if, that condition is true, it opens the gate and lets the code inside run. Okay, let's make this real with some code. So we've got a variable here, num, and we've set it to 3. The if statement then asks the question, is num greater than 0? Well, since 3 is greater than 0, that's a yes. The condition is true, the gatekeeper opens the gate, and our print message runs. Simple with that. So that's the logical next question, isn't it? In that last example, if the number wasn't greater than 0, what would happen? Well, the program would just do nothing. It'd skip right over that print statement. And sometimes that's not quite what we want. And this is where the else statement comes in to save the day. It gives us an alternative path for when that if condition is false. So here, num is -1. The code asks, is -1 greater than 0? The answer is no. So the if block is totally skipped, and the code inside the else block gets to run instead. It's a true fork in the road, one path or the other, but it can never be both. Great, so we can handle two paths, a yes or a no. But, life is usually a bit more complicated than that. What happens when you have 3 or 4 or even more possibilities that you need to check? Before we even peek at the code, let's just think through the logic here. The program is going to start at the very top with the first if. If that's not true, it just moved on to the next check in line, the elif. It'll keep going down the line, checking each elif one by one until it finds one that's true. And if it gets all the way to the very end and nothing has been true, well, that's when it runs the final else block as a kind of catch-all. And here's what it looks like in actual code. Elif is just a short way of saying else if, and it lets us chain all these checks together. So first, we check if a number is positive. If not, okay, let's elif check if it's 0. If neither of those is true, then the final else block catches the only remaining possibility, that the number must be negative. This whole structure is amazing because it guarantees that exactly one of these blocks will run. Okay, this is awesome. We've basically given our code a brain. It can make choices. Now, let's give it a toolbox so we don't have to keep writing the same logic over and over and over again. And this is where functions come in. A function really is just a way to package up a piece of code, give it a name, and then call on that name whenever you need it. You are literally building your own custom tools for your toolbox. So here's the basic blueprint for any function. We kick things off with the keyword def, which just stands for define. Then we give our function a name that's unique. Everything that's indented underneath this line, that's all part of our new tool. Let's just break that down really quick. So def tells Python, hey, I'm starting a function. You give it a unique function name. Now, inside those parentheses, you can list parameters. Think of these as inputs the function needs to do its job. The colon at the end just marks the end of that definition line. And finally, you have the optional return keyword, which lets the function send a result back out to wherever it was called from. All right, theory is great, but let's see how this stuff actually works. It's time to put these new tools we've built to good use. So take a look at this greet function. Its job is to say hello, but by including name as an input as a parameter, we've made it super flexible. We can call this function and pass in any name we want,
and it'll print out a custom message every single time. We write the logic just once, and we can reuse it forever. That's the power.
Okay, we have learned about making decisions, and we've learned about creating reusable tools. Now for the real payoff. This, right here, this is where it all comes together.
This is the key moment. Look at this. We've created a function, our own custom tool called abs_value, and inside that function, we have put an if-else decision block. Our custom tool now has its own internal brain. It takes a number, it checks if it's greater than or equal to 0, and then it decides what value to send back or return.
So let's just pause and appreciate what we just did. This is so important. We've combined our building blocks. We didn't just write some code, we built a small, smart, reusable machine that performs a specific task, a task that involves making a decision. That, right there, is the absolute core of what programming is all about. We've just put together the two most essential building blocks in all of programming, the ability to make choices and the ability to package those choices into reusable tools. From here, the possibilities are genuinely endless. So, you have the first blocks. What are you going to build?